Okay, so let's have a look at an example where what they have given you are the three x-intercepts and you have to find the equation of the cubic function, okay? Just like we've done in the previous video, the example is slightly different, however, because in the previous example in the video, I gave you the diagram, okay? So you had the picture in front of you and you had to find the equation. This example is pretty much exactly the same story. The only difference is that there's no picture. There's no actual graph, okay? Everything's been given to you in words like this, okay? So it's just a case of being able to recognize that it's asking the same thing, all right? Let's see. It says f of x of the x cubed, ax cubed, bx squared, cx plus d is of the graph is passing through. And now here's the important stuff. So it's passing through a point of x and 0, 0 and 12, 1 and 0, and then this negative 2 and 0. So let's think about this here. When y equals 0, that's an x-intercept, okay? So if y is equal to 0, then 6 has got to be an x-intercept. If y is equal to 0, then obviously 1 is an x-intercept. And if y is equal to 0, then negative 2 is an x-intercept, all right? This one over here is where x is equal to 0. So in fact, if x is equal to 0, then this point over here is a y-intercept. It's not an x-intercept. But to start off with, it's the x-intercepts that I'm interested in. Those are the ones that are going to have me kind of set me on the path of working this out, okay? So we have to determine the values of the a, this a here, the b, the c, and the d, okay? Where do we start, okay? What did we say in the previous video? We said that if you've been given three x-intercepts, your starting point is to say a x minus x1 multiplied by x minus x2 multiplied by x minus x3, okay? And the three x-intercepts that have been given to you obviously are getting substituted into those x1s, 2s, and 3s. So I've got a minus 6, I have got a minus 1, and a negative 2 means two negatives make a positive, so that's going to be x plus 2. All right. What did we then do with that other point? The other point, we used the x and the y coordinates to substitute into the x and the y values of your equation. So y is getting substituted with 12, and all the x's are getting substituted with zeros. Okay. All right, and what is that giving you? So we've got 12 is equal to, I've got negative 6, I've got negative 1, and I have got 2, and that's very nicely giving us 12a. And 12 divided by 12 is giving me a value of 1. All right, so that works out nicely. And again, now we go back to this and we say, okay, well, if I know the a value and I knew that these three brackets were as they were, then that's where we go to, and we say, let's do it in red. Let's say I've got y equals a, which is now 1, and then we've got the three brackets of x minus 6, x minus 1, and x plus 2. And now it's a case of foiling it out. Okay, so a little bit of time to just do it carefully, but nothing too difficult with that. Foil your first two brackets out. Once they're foiled, you distribute the other bracket. That is going to give you, I'm just going to give you the final answer because otherwise it's a whole lot of working out to watch me do, is 5x squared minus 8x and plus 12. Okay, and obviously I got there by foiling the first two brackets, then distributing x minus 6 into that foiled bracket and simplifying. Okay, so just to make sure you obviously answer the question as they asked it, they wanted to know the values of the a, the b, the c, and the d. So you want to then just say, therefore a was a value of 1, b is a value of negative 5, c is a value of negative 8, and d, which is your constant term, was 12. All right. There we go. So that's how we find the equation of a graph if we have been given three x-intercepts. Well done.